Hi, we have reached the fun part of Java 8. Why we use functional programming in Java 8? Because it's so simple to process data. In the very first chapter of functional programming in Java 8, I have showed you this example. We read some data from a text file and filter the lines that does not start with error, and then we limit the result set as 40 items, and then we transform the result set to a list. We just read the lines from text file line by line. After that, we process these lines and eliminate the lines that does not start with error. And then we get the result set and limit the items as 40 lines. That means when you reach 40 proper items, the processing will be done, it will be completed, and then we get this result set and transform it into a list. Now this makes sense for you. This is just a predicate and checks if this line, the given string, starts with error or not, and if it does not start with error, it will be eliminated. Otherwise, it will be collected into the result set, and this result set will be an output to other line, to next operation, and when we reach 40 lines, the processing will be done, and all the lines will be collected into a list. All of these operations are done on streams. When you use this statement, the lines inside the text file gets you one by one. Not at once, but one by one. So you read a line, after that you check this line with this filter, and if it starts with error, it will be put into the result set, and the other line will be read, and if the other line also proper, it will be again put into the result set until 40 items has been reached. Okay? After all of the lines has been collected, these lines will be transformed into a list. So the result of these chained operations is a list of string. There will be 40 items. This point is important. All of these lines gets you one by one, not at once. Please don't forget this. So let's talk about the theory of the streams. In functional programming with Java 8, we use streams inside of collections. In fact, we use the collections to store the data, that's right, but when we need to process, filter, group this data, we just use streams. That's why we use these collections and transform them into a stream object, and then use this stream to process all the data, all the items in functional style. While doing this, the original connection is not modified in any ways, so nothing changes inside the original collection, but the references of all the items has been passed to the stream, so that you may process all the items one by one inside your stream in functional style. The other important point is that when you reach a result after all of the operations with the stream object, you cannot reuse this stream. If you want to reprocess this stream, you need to create a new stream from the original collection. Now let me schematize what a stream does. Inside our Java application, we have a collection. This may be a map, list, or set, and we use a special function of the collections and transform them into a stream. Okay, so this pipe is a stream now, and all the objects are flowing into the stream one by one without removing them from the original collection, and we process this collection till we got a solution to find a result, a single result. This single result may be another collection, or it may be an integer or something else. Let's see the example. We have the balls here with different colors and sizes, and let's say we have a filter here that corresponds to a predicate, and this predicate simply filter the red ones, so the red ones are eliminated inside this predicate, and the remaining items flowing to the other predicate or other transform function. In our example, we have a function here which is chained to this predicate, and it simply transforms these spheres into triangles. So we transform the data, and now they are triangle. Again, here we have another predicate that filters the small triangles. So here we only have the big triangles. Okay? Here, each functional interface outputs another stream so that the next functional interface may process the data coming to it. Okay? So the result of this functional interface is stream, it is stream again, it is again stream. While the output is a stream, the processing is not completed yet. But when the result is a collection, such as map, list, or set, or it is a regular object, the processing is done. So in our case, this functional interface sums up the circumferences of these triangles and gets an integer value. It is 20, and when we reach a regular object, a single object, all the processing of the streams are done. We call these operations as intermediate operations because they get a stream and output another stream, but we call this operation as terminal operation because it gets a stream but outputs a regular object or collection. In next chapter we will talk about intermediate operations and terminal operations. See you then.